All right, 3.6, quadratic inequalities, which is on page 140 to 143. Graphing quadratic inequalities is really similar to graphing linear inequalities. You're basically going to graph the parabola, all right, and then we have to change it, and basically we change it this way. You are going to dash the parabola if it is a less than or greater than sign, and you're going to make a solid line or parabola for inequalities that have a less than or equal to or greater than or equal to sign. Part 2, you can plot a point and see if it works and shade that region. To me, it's much easier just to use this. If it is less than or equal to, you shade down towards the bottom of the page. Sorry. If it is greater than or equal to, you shade up towards the top of the page. All right, so flip it up. Here we go. Concept number 1, graphing a quadratic inequality. Well, I'm going to start right here at the sign, because that's really the biggest thing here. So, looking at that sign right there, greater than. What does greater than tell me? Well, it tells me it is dashed, and I shade up. Those two things. That is it. That is basically what I need to know there. Now I'm just going to graph as it was if it was an equal sign. Okay, so here we go. Y equals negative x squared minus 2x minus 1. Standard form. First thing I want to do is find my axis of symmetry. X equals negative b over 2 times a. In this case, that's opposite of negative 2, which is positive 2 over 2 times negative 1. So that's 2 over negative 2, and that is negative 1. Okay, what I'm going to do is f of negative 1 in there. So that's negative, or the opposite of negative 1 squared, minus 2 times negative 1 minus 1. All right, so negative 1 squared is 1. Opposite that's negative 1. Negative 2 and negative 1 multiplied to give me positive 2, and then minus 1. That's negative 2 and 2, and that's all canceled out to give me 0. So my vertex is negative 1, 0. Axis of symmetry at x equals negative 1, right? So just go ahead and write that AOS here. Axis of symmetry, negative 1. All right, there's my axis of symmetry, the mirror image. My vertex is at negative 1, 0, right there. Plot that point. The next point I'm going to use is my shortcut, which is 0c, which in this case is 0, negative 1. All right, plot that right there, 0, negative 1. Then use the axis of symmetry to go ahead and move it on over to the other side. Voila. And now, since I chose 0, right, I'm going to go ahead and choose x as 1 for my next part. So x equals 1. I do f of 1. And that's the opposite of 1 squared minus 2 times 1 minus 1. That's negative 1 minus 2 minus 1, and that's negative 4. So I get the point 1, negative 4. Okay, that's 1 to the right down. 1, 2, 3, 4, right there. And it's 2 to the right of the axis of symmetry, so I just go on that part, and 2 to the left. Okay, and now this is the part that really is the different part, right? I now go up here and say, is my line solid or dashed? Well, greater than was just dashed, so I'm going to go ahead and dash the line. Okay, dashed. And then the next part really, and maybe I do it in a different color just so you can see. I probably should dash it in a different color maybe, but do I shade above the parabola or below it? Well, again, greater than means I'm going to shade up towards the top. So again, I just kind of like to make arrows going up. You know, you can kind of dash up or like shade up. Sorry, dash. Shade up works. And now any one of these points would be part of that inequality. Okay, so if I say 1, 1, 2, 3, 4, up to that point right there, is that work in this inequality? Yep, it works, right? This point over here would work. This point over here would work. What about this point right here? No, that point wouldn't work because it's not shaded. Okay, so basically, you are going to go about this the exact same way you'd graph any parabola. The only difference is you're going to identify if it's dashed or solid, shading up or shading down, and then apply that to your graph. Okay, I want you to try number 2. Take some time to work through it. And I'm going to go ahead and show you the answer now. So pause as I show you the solution. Okay, so keys to number 2. It is less than or equal to, which means it's solid, and I'm going to shade down. Change your inequality to an equal sign. Graph the parabola as normal, right? Find your axis of symmetry, find your vertex, use your shortcut, find another point, get 5 points, make it nice and accurate. Okay, then from there, make your parabola. Here I had a solid line, and then I also shaded down towards the bottom of the page. There it is. We got one more concept to do, concept number 2. And this time I'm going to go ahead and solve this inequality algebraically, sorry. So here's how this one works. Really similar in a sense. All right. So what I'm going to do is I'm going to take my inequality and I'm going to make it an equal sign. So I get x squared minus 3x minus 4 equals 0. And now what I'm going to do is just solve for x. Sorry, I changed it. Solve for x. All right, so in this case, I can see it's factorable. I can think of 2 numbers that multiply to give me -4 that add up to give me -3. Well, I know it's going to be positive and negative. And in this case, it's going to be -4 and 1. -4 and 1 give me -3. -4 times 1 gives me -4. Set each factor equal to 0. And solve. Subtract 1 from both sides, add 4 to both sides. And now I get x equals -1 and 4. Okay, perfect. That's the first part. Now, this may seem a little crazy and totally different for a lot of you guys, but next I need to make a number line. And when I make this number line, I do want values less than -1, in between -1 and 4, and greater than 4. So let me show you what I'm talking about. So over here, I can make a straight line like so. All right, and I'm going to go ahead and start on this side. I'm going to make it -2, -1, 0, 1, 2, 3, 4, and 5. Okay, standard number line. Values less than -1 and greater than 4. Okay. Then what I'm going to do is I'm really going to kind of make like dash marks here. And I just do dash marks really to verify, because I have really -1 here and 4. So I'm going to even circle those, and I'm going to make a couple dash marks here just to keep things kind of on that side. And then I'm going to go ahead and write inequalities in there. So for the less than negative 1, all right, I'm going to use negative 2. So what I'm going to do is basically just plug in negative 2 in for x, negative 2 squared, minus 3 times negative 2, minus 4, and is that less than 0? I'm sorry, I had to go a little past that dash mark. Okay, so negative 2 squared is 4. Negative 3 and negative 2 multiplied to give me positive 6, minus 4, is that less than 0? Well, the 4's cancel. Is 6 less than 0? No, right? So that means it doesn't go over here. All right? And really what I'm doing is I'm making a compound inequality with this because it's quadratic. And one equality would go one way, but if you get compound inequalities, it's everything in between two numbers or everything less than or greater than two numbers. I'm going to choose another marker here, do what's in the middle, in between negative 1 and 4. Anytime I have a chance to use 0, I tend to use 0. It does make things really easy for me. And I use 0 in my original inequality up here. So 0 squared minus 3 times 0 minus 4, is that less than 0? 0 squared, 0. I get 0 minus 4 is less than 0. Is negative 4 less than 0? Yeah, right? Yes, for sure it is. Therefore, everything in between this works. All right, so is 3 a solution to this inequality? Yes. Is 0 a solution to the inequality? Yes. Is 2 a solution to the inequality? Yes. Is negative 5 a solution to the inequality? No. It would be over here. All right, I'm going to do the last one here. And I'm going to use 5 this time because it has to be greater than 4. All right, so here we go. 5 squared minus 3 times 5 minus 4, is that less than 0? Well, I get 25 minus 15 minus 4, is that less than 0? Well, that's 10 minus 4, that's 6. Is 6 less than 0? Nope, it definitely is not, so that will not work. Therefore, the only part of the solution that works is in between negative 1 and 4. Okay, so we did all that to now write the solution. And when we write it, you write it as a compound inequality. And for this compound inequality, it looks like this. Everything in between negative 1 and 4, you write it like this. Negative 1 is less than x, which is less than 4. And that is the solution I am looking for. Okay, I'm going to ask that you try number 4. Do the best you can. I know there's a lot of steps there. Look at all the steps that I have, check your answer, and do the best you can. All right, please pause now because I'm going to show the answer to number 4. Okay, here we go. Set it equal to 0, solve for negative 8 and 4, put it on a number line, test the number to the left of negative 8 or less than negative 8, like negative 9, test a number in between negative 8 and 4, like 0, test a number greater than 4, like 5, and you'll see that it works. Anything less than negative 8 and greater than 5. It does not work in the middle this time, so this time you write your compound inequality as everything, or x is less than negative 8 or greater than 4. Hope that makes sense to everybody. That's all I have for this 3.6 notes, and that is it for the unit. Take it easy.